Welcome back, Tech Explorers. Today we're diving into something huge. Google just dropped a major bombshell, a brand new quantum computing breakthrough that's blowing classical computers out of the water. And guess what? It's not just a win for Google. It could completely reshape the future for companies like IonQ, D-Wave, and Rigetti, three of the biggest pure-play quantum computing stocks in the US market. So, what does this really mean for investors, students, and anyone curious about the next big wave after AI? Let's break it down, simply, clearly, and with some cool visuals. A few days ago, Google's CEO Sundar Pichai posted something exciting. Their quantum computer, called Willow, just ran a quantum algorithm 13,000 times faster than the best classical supercomputer could. That's like running a race where your opponent takes 4 hours and you finish in less than a second. Pretty wild, right? This milestone is what scientists call quantum advantage, when a quantum computer solves a problem impossible or impractical for regular computers. And what's even cooler, the algorithm wasn't just a random test, it simulated atomic interactions in molecules. That's big, because molecular simulations are the foundation of things like drug discovery, materials science, and even AI chip design. So in short, Google didn't just win a race, it opened a door. Okay, let's slow down for a sec. To really get what's going on here, you need to understand how quantum computing is different from normal computing. Regular computers, like the one you're watching this on, use bits. Each bit can be a 1 or a 0, simple on-off switches. Quantum computers use qubits. Think of them as tiny particles that can be 1, 0, or both at once thanks to quantum physics. Because qubits can exist in multiple states at once, a quantum computer can process massive numbers of possibilities simultaneously. That's why problems that take classical computers thousands of years could someday be solved in minutes or seconds with quantum computing. For the past few years, people have been asking, is quantum computing real, or just hype? Well, Google's latest results are a pretty solid answer. It's real, and it's coming fast. Every time a big player like Google makes progress, it does two things. It proves that the technology actually works. It pulls more money and attention into the entire quantum ecosystem. And that's where companies like IonQ, D-Wave, and Rigetti come in. They might not be as rich as Google, but they're laser-focused on turning quantum hardware into real businesses. IonQ is based in Maryland, and it uses something called trapped ion technology. Imagine holding a few charged atoms in place with lasers and using them as qubits. That's what IonQ does. Their qubits are extremely stable and accurate, which gives them a head start in reliability. They already have their quantum systems available on Amazon Web Services, AWS, and Microsoft Azure, so researchers and companies can test problems directly in the cloud. Now here's where Google's news helps them. When people see Google achieving quantum advantage, they start believing quantum computing is real. That makes it much easier for companies like IonQ to get customers, attract investors, and win government contracts. Think of Google as opening the door, and IonQ walking through it with its own machines ready to rent. D-Wave is a little different. It focuses on quantum annealing, not general quantum computing. What's that mean? Well, instead of solving all kinds of problems, D-Wave's machines are built for optimization, finding the best possible solution among millions of choices. Think scheduling airline flights, designing circuits, or optimizing logistics routes. Even though Google's result used a different model, D-Wave still wins from the hype wave. When big breakthroughs make headlines, it drives companies to try some form of quantum solution. And D-Wave already sells that kind of service to businesses like Lockheed Martin and Volkswagen. So while Google may grab the science spotlight, D-Wave can quietly grow its commercial customer base. Rigetti uses superconducting qubits similar to Google and IBM. They build the entire system, the chip, the cooling systems, the software, all in-house. They're kind of like the independent Tesla of quantum computing, small, scrappy, but full stack. Google's announcement directly helps Rigetti because it validates the superconducting approach. It tells investors, hey, this architecture really works. That's fuel for Rigetti's roadmap, partnerships, and, hopefully, its stock price. Now, if you're a student or retail investor thinking, should I buy these quantum stocks? Slow down a bit. Here's the thing. Quantum computing is still early stage. These companies make tiny revenue compared to their market caps. They're burning cash for R&D, and profits may still be years away. But, and this is a big but, whenever a breakthrough like Google's happens, it usually gives the whole sector a boost, because it reminds investors that the technology isn't fantasy, it's inevitable. If you believe quantum computing will one day power AI, cybersecurity, and drug design, then companies like IonQ, D-Wave, and Rigetti are the early bets in that race. You might be thinking, okay, cool. But how does this connect to AI? Great question. AI needs massive computing power. Training large models like ChatGPT or Gemini requires millions of calculations per second. Quantum computing could eventually make that much faster and more energy efficient. Here's how. Quantum computers can simulate neural networks in new ways, potentially optimizing weights or searching vast datasets faster. They can help design new materials for faster AI chips, like discovering better superconductors or ultra-efficient transistors. They can help model atomic-scale systems, which might lead to better cooling tech or energy storage for giant data centers. Now, let's be real. Quantum computers aren't about to replace your laptop tomorrow. There are still some big challenges. Error correction. Quantum bits are super sensitive. A tiny vibration can mess up a calculation. Scalability. Most current systems have fewer than 500 reliable qubits. We may need millions for practical use. Cost. Cooling systems, isolation chambers, and precision control are extremely expensive, but these problems are being solved faster than most people expected. And each milestone, like Google's Willow chip, brings us a step closer to commercial-grade quantum computing. So, what happens now in the global race? There's a clear divide. The US has players like Google, IBM, IonQ, Rigetti, and D-Wave. China is also investing heavily in quantum research, often backed by government funding. The European Union, Canada, and Japan are all running national quantum programs too. The competition is about more than technology. It's about data security, AI leadership, and national defense. That's why every US breakthrough, like Google's, strengthens the domestic ecosystem and makes funding for smaller American quantum firms more likely. Whenever a big tech breakthrough hits headlines, quantum stocks usually pop. Investors suddenly remember, oh right, IonQ exists. But remember, short-term jumps don't always last. Here's the pattern we've seen before. News breaks. Stocks spike 20–40%, reality check hits. Prices cool off. Real adoption builds slowly over years. So, if you're investing, think long-term. You're not buying for next quarter. You're buying for the next decade. This is like investing in semiconductors in the 1970s, or cloud computing in the early 2000s. It'll take time, but those who understand it early could see major rewards later. If you're following this space, here are 5 key things to watch: qubit count and fidelity. Are these companies increasing reliable qubits each year? Error correction breakthroughs. Anyone solving this will leap ahead. Government contracts. Watch for deals with NASA, DoD, or the national labs. Enterprise partnerships. Companies like Amazon, Google Cloud, and Microsoft are integrating quantum services. Who gets included? Actual use cases. The first real business applications, like drug design or logistics optimization, will be game changers. Imagine a world where new medicines are discovered in days, not years. AI learns from nature itself. Cybersecurity becomes unbreakable, or breakable again in new ways. That's the promise of quantum computing. Google's latest breakthrough is like the Wright brothers' first flight. Short, simple, but historic. Now the race is on. Who will build the Boeing 747 of quantum? Will it be Google? Or will smaller pioneers like IonQ, D-Wave, and Rigetti surprise everyone? Only time will tell. Thanks for watching, everyone. If you learned something new today, drop a like, hit subscribe, and share this video with your friends who love science and tech. And tell me in the comments, which quantum stock do you think will lead the next wave? IonQ, D-Wave, or Rigetti? Until next time, stay curious, stay informed, and keep thinking quantum.